Fabulous, Aaron, if you wouldn't mind doing that. Of course. All right, Mr. Spielberg, tell me when you're ready.
Ready.
Excellent. All right, so let's see how well I taught this yesterday. In order for a limit to exist, what has to be true? Hey, everybody should be able to do this one.
The left and right.
The limit from the left and the limit from the right must be equal to each other. Don't stop there.
Holes are okay.
Holes are okay. Now pause. Time. Holes are okay because when we talk about limits, we talk about getting close. I don't actually care in the world of limits. I don't care what happens at that point. I just say if this is x equals c, and as I get arbitrarily close to c, if the y values are getting closer and closer to L, then we're all going to say the limit as x approaches c of f of x is equal to L. Everybody all right with that? Tight like my pants. Good. So in order for a limit to exist, the limit from the left, the limit from the right have to be equal to each other. A hole is okay. How do we feel about a jump?
Jumps, breaks.
No jumps because limit from the left, limit from the right, not the same. How do we feel about a break in the graph? Not okay. And how do we feel about, you know, the vertical asymptote? How do we feel about that? Not okay either. Good. So there are three reasons, count them, three reasons why you might say a limit does not exist. Anybody remember one of them? Go for it.
The limit does not exist because of unbounded.
Limit DNE because of unbounded. Finish off that thought. Oh no, finish that thought off correctly.
Oh.
Behavior. Aaron's leaving on the desk. You're so good to me. Thank you very much. I'm telling you, the room catches on fire, I'll get you and the camera out of here. Okay. Limit does not exist because of unbounded behavior. I want you to think about, like, you've got an asymptote. The graph does something like that, right? If this is x equals c, this is the kind of stuff before that maybe with Mr. Link last year, you guys would say limit as x approaches c from the left of f of x is equal to infinity. And that's what the College Board has said, no bueno, no more. Instead, we're going to say limit does not exist because of unbounded behavior. Everybody okay? That's one reason. You're frozen. What's another reason the limit wouldn't exist? Go for it.
Limit doesn't exist because of oscillation.
Limit does not exist. Limit does not exist because of oscillation. Right? Just the graph wiggles. Right? So the graph maybe looks something like that. It just, right, you're not getting closer to any one particular number. So in this case, I'd say something like the limit as x approaches infinity of f of x does not exist because of oscillation. And the third reason that a limit doesn't exist, we've already talked about this, so it's not a surprise to anybody.
Left and right.
Right, limit from the left, limit from the right are not equal to each other. So for example, your graph might look something like that. Here's x equals c, and what I'd want to see on a paper is the limit as x approaches c of f of x does not exist because the limit as x approaches c from the left of f of x, I'll move my bahonkus out of the way in a second. Limit doesn't exist because the limit as x approaches c from the left not equal to the limit as x approaches c from the right. You never get to just say limit doesn't exist. You're going to have to tell me limit doesn't exist. Because. Are you two okay? Do you guys have your calculus back?
Oh.
You were just so in awe of all this beautiful math, and you're like, just teach me, big boy. Yeah, if you say that, you'll die. All the friends okay? All right, so quick recap to tonight's homework. You were so good. I see you copying it all down. There. Yesterday, you guys would have picked up 2 packets. One of them was like 58 pages, and then another one was like 8 or 9 pages. The big hunkin' packet is like the notes packet. That's like all the stuff you're going to be using in class every single day. You should have it out right when you walk in. The other thing says like problem set packet. You will see assignment number 2. This is not on the first page, it's assignment number 2. What I'm going to ask you guys to do tonight, problems 1 through 4, 6, 10 through 13, and 16 through 18. This should not take you more than 45 minutes. You're in Calculus BC? I have permission. Okay, so please, pinky promise, don't spend more than 45 minutes on this. Okay, I need to come over here and ask Holly Moan a different pinky promise. Don't spend less than 45 minutes on this. Okay, don't try to get this done in like a passing period tomorrow morning or on the way to the bus. Oh no. All right. Other thing, graphing calculator. When does that show up?
Today?
And like every day. That thing is with you every single day. I'm not saying you're going to need it every single day, but bring it every single day. The other thing you should have with you every single day would be your binder. Okay. And tomorrow, make sure that you bring in the syllabus signed by Mom or Dad, or Stranger Bob, who likes to wander up and down Anderson Road. Doesn't matter to me.
Wait,
Someone who'll take legal responsibility from you.
can we turn it today?
Huh?
Can we turn it today?
Can you hold on to it till tomorrow?
Yes.
Thanks. Steven, you okay?
Yeah.
Please do not go up to Stranger Bob. Okay?
I will.
He could be playing Pokemon Go, and he's got other things going on. Okay? I need to play some Pokemon Go because I'm only on level 15. All right. So, friends, let's go back to the world of limits. Oh my God, I love limits. Love them. Love them, love them, love them. All right. So, let's see what you all know about limits. I would imagine for some of you this is going to be very comfortable, and if I'm not going fast enough, feel free to go as fast as you can. Okay, I'm on page 16 in the packet. Okay. These are, like, I would say you really deeply understand limits if you can do all of these problems. Okay, I'm going to go through most of these. We're going to have some conversation. But for all like the wicked smart people in the room, if I'm not going fast enough, just keep going. Okay? All right, so problem number 1. Let's take a couple of seconds to think about this. What are you going to do? What thoughts come to mind? Hello, Miss Bauer. Lewis, what thoughts you got?
Square h. I thought square, so multiply h plus 2 times h plus 2.
So you want to do h plus 2 times h plus 2 and do some stuff? What other thoughts are out there? I'd love to hear from more friends. What other thoughts do you have out there? Was everybody going to do what Lewis just did? Go for it.
I was thinking of choosing numbers coming from the left to 0 and from the right and plug those in.
Oh, God, I love that. Say that one more time. I want to make sure everybody can hear that.
I was going to choose some numbers coming from the left and right of 0 and plug them in for h.
Okay, so what I hear is you're going to do like a lot of calculations here. You're like, let me plug in numbers close to 0. On the left, see what happens. On to the right of 0, see what happens. We're okay? Great ideas. What else is out there? There must be other ideas. Go for it.
Plug in 0 for h.
Oh, plug in 0 for h.
Yes.
Was anybody else going to do that? No, no one was going to do that?
Yes.
Okay, now here's my question. What happens if you plug in 0 for h?
The denominator is going to be 0.
Gonna be undefined.
Okay, we're going to get bad stuff that's going to happen. If you plug in 0 in the top, you're going to get what? 2 squared minus, what, negative 2 squared over 0. And some of you are like, hey, that's a perfectly good answer. How do you feel about that? It's undefined. Tell me why.
It's not divisible by 0.
Okay, we can't divide anything by 0 ever, right? We will never be dividing by 0. But if you look more closely at this, this has a different problem. It's not just that we're trying to divide by 0. Look at the numerator. Aaron, what's happening in the numerator?
We'll pick them up to the same value.
What is that same value?
4 minus 4, which is
You're going to get 4 minus 4 over 0, which is 0 over 0. Anybody know what 0 over 0 is?
Indeterminate.
Complex.
Terrible. Indeterminate form.
Complex.
A complex root. Now we're throwing out all the vocabulary terms. Would anybody want to argue that 0 divided by 0 should be 1?
Huh.
Can anybody think of a math rule that you've learned at some point in your career? Only Lewis?
I mean,
Why might somebody look at this and say, I think the answer is 1? Stephen, why?
because people think any number divided by like itself is gonna be 1.
Right? The misconception is a number divided by itself is 1. Is that true?
Yes.
Yes, except not with 0.
0 is not considered a number.
Okay, so some people are going to say 1. Other people are going to say 0. Why are other people saying 0?
So why are other people doing
Yeah, why might other people argue 0? Go for it.
Because if you have nothing and you divide it by nothing, you have nothing.
That's a whole lot of nothing. I have nothing, I've divided it by nothing, and I get nothing. How about, there's a rule that you learned in like 2nd grade, 3rd grade, 4th grade, right? 0 divided by a number is?
0?
I have 0 pizza, my 4 friends come on over, how much pizza does everybody get? 0, right? So some people are going to argue 0, and then we have the apocalyptic people who are like, oh my God, this can't be done. I can't divide by 0 ever. The universe will explode. Who's right? Is the answer 1? Is it 0? Is it can't be done?
Well, if you go by rules, then all 3 of them would be correct technically.
If you are a rule follower, Aaron, I'm so glad that you said it that way, you might argue, well, it's going to be one of these 3. This is actually known as an indeterminate form. Indeterminate form. The way that we handle an indeterminate form is with algebraic manipulation. We're going to do legal algebra things because direct substitution doesn't work. We get to this indeterminate form. So I want to come back to Lewis, your thought, which was, like you wanted to do some algebra? Okay. So limit as h approaches 0, h plus 2 squared. I know we've been on summer break for a while. If you need to go on the side, h plus 2 times h plus 2.
It's h squared plus 4h plus 4.
Aaron, thank you for that. H squared plus 4h plus 4 minus, oh, now I've got to go on the side, h minus 2, h minus 2. I've got to multiply that out.
H squared minus 4h plus 4.
Okay, and Aaron, I'm going to freeze you just for a little while. You will thaw eventually, I promise. Is everybody okay with the algebra?
Yes.
Yeah.
Nothing but algebra happening. I need more legal moves. What else is in your bag of tricks? Lewis, you're also frozen for a little bit. Aaron is frozen for a little bit. Yes, ma'am? I can distribute the negative through legal stuff, right? Negative h squared plus 4h minus 4. Any other legal things that you see?
Well, once you distribute, then the numbers will cancel out on top.
Can you give me an example of something that cancels?
The 4 inside the parentheses will be negative 4, so the 4 and the negative 4 will cancel out.
Positive 4, negative 4. Love it. Give me something else that cancels.
H squared minus h squared.
H squared minus h squared cancel. Get that out of there. 4h minus a negative 4h.
8h.
What is that? 4h minus negative 4h. Oh, so awkward.
Oh, 80.
4h minus a negative 4h.
8h over
8h. Divided by h. If you try direct substitution now, guess what? Still 0 over 0. Still no bueno.
The h's can cancel out.
Your h's can cancel. Is that legal algebra stuff?
Yes.
Absolutely. Okay, Aaron's starting to thaw himself out. So the limit as h approaches 0 of 8 is 8. Direct substitution, the thing that we tried in the beginning, doesn't work. It leads to this indeterminate form. That's not going to be your final answer. Sometimes I'm like, indeterminate form, uh-oh, gotta go try some algebra. And then we tried all the algebra that we could do to get over here. All the friends okay? All right, I want you guys to take a couple minutes, see what you can do. We're gonna skip number 2 for right now. 3A and 3B. can definitely help each other out if you'd like to. And we're going to avoid the awkward moment where someone says, you're asking me to do the same problem twice. Not happening.
So are you going to wait till left? So wait, are you going to start your denominator
You don't plug it, you don't plug it in the middle.
to get rid of the W? Move what up to the top?
They multiply by the complex country.
So I don't know. Talk to your friend here.
So you're going to multiply by the W to get the root out of
Yes,
it.
sir, that is correct.
And then you're going to put this up here, so it'll be W minus 4 times W. And then you distribute it to W squared minus 4W.
Oh my gosh. All these people that like pain. We're going to have to find a support group for all the friends here. Everyone is going the way of pain. Every single person in the room. Maybe not the 5 trailblazers, but everyone is going the way of pain. Pain lovers over here.
Oh, wait.
Hold
Just
on.
plug it in.
One more time.
You just plug it in.
Can
Yeah, I did
you
that.
just
Yeah.
plug in here?
Yes.
Yes! If you did, now we're in Calculus BC, so we need to make it sound fancier than that. Not plug in, but like evaluate, direct substitution,
Direct substitution.
right? What happens over here? 4 minus 4,
And then 2 plus 2.
square root of 4 plus 2. So you're going to get 0 over 4. How do we feel about 0 over 4?
Pretty good.
0 over 4, no problems here. Life is good. 3A meant to be quick and easy. 3B
Not so much.
might be a little bit different.
Wait, what?
Okay, David?
Yeah.
Oh, I see. Yeah. How was that way?
Now you can do it.
Alright, now we're going to do the thing we did up top. So now you do what you just did. When you tried to bring the W up by multiplying by W on both top and bottom.
Did you want? Oh, Aaron, you did the complex country.
Huh?
You did the complex country. Where
Yeah,
you
we multiply by W on the denominator and the numerator. Here in
Just
W.
W.
Huh?
Just W.
Well, I thought it was the whole thing. Isn't it? Okay, so then you get. Huh?
Put it like.
Oh, plus 2 to, like, you're doing the complex conjugate, right?
Yeah.
So yeah, then it'd be the W squared plus 2.
Yeah.
If you're doing that, but if not, then you're just trying to cancel out things. You don't have to, but it's the easier way to.
Yeah.
So you have this.
Okay, quick show of hands. How many of y'all are multiplying by this thing called the conjugate? Okay. Polymon, what do I mean by the conjugate?
I learned the terms and didn't know how to do the math.
Oh, well, okay, that's a math class, so you're like, hooray, we're partially there. Why are people multiplying by the conjugate, even if you don't have the word for it? Why are we doing this? Why?
To eliminate the square root.
Basically a fancy.
Polymon, why?
To get rid of the square root.
Because you see that square root of the denominator. Now, did everybody actually try plugging in first?
Yeah.
Yes.
You didn't.
I got
Okay. So you get 4 minus 4 over the square root of 4 minus 2. You're getting 0 over 0. This is the problem. This is why we need to do some other stuff, like rationalizing the denominator. Not the complex conjugate, that's something different, but they're related. Now here's the thing that I don't like, and Mr. Link, I'm sure, is going to not like it as well. I'm seeing a whole lot of folks
Oh,
that have that written down,
no.
and I like it, I don't love it. You want me to love it.
It makes it hard.
I like it, I don't love it, I will not give full credit for this. Does anybody know why?
It makes it really different.
What's wrong? There's something missing. Lewis, what's missing? Oh, shame. I'm so glad that we're catching this now. We're evaluating a limit, right?
Yes.
The limit needs to be there. I need to see limit as W approaches 4. I know you're like, for real that picky? Yes, for real that picky. Now here's the thing, I am pretty convinced that all the friends in the room are able to correctly multiply out the denominator. And you're going to get W minus 4. In the numerator, maybe you're going to leave W minus 4 and the square root of W plus 2. And some of you are going to be like, oh, cancel, cancel. And then you're going to write the square root of W plus 2. And all I can say is, yeah, that's right, but it's not 100% correct. I like it, I don't love it.
Carry the limit.
I need that limit all the way through. It is like, anybody have a little brother? That annoying little brother that follows you everywhere that you go? We get that Ms. Blakely for that. Limit W approaches 4. Limit W approaches 4. That limit is going to be the square root of 4 plus 2, which is 4. I am 95% convinced most of you guys are going to get the right number, but I care deeply about the notation. Okay. Everybody okay with 3A and 3B? Mostly okay? All right, see what you can do with 4A and 4B. We'll talk about 4 minutes.
Huh?
Oh, you plug
in 0 for theta.
Plug that in, you get
It's the sign of 0, 1, right? No. That's sign of 0, 1, right?
it'd be a 0 there. That's a no.
No, wait a minute.
Yeah, because
The sign of 0 is 0, right?
0.
Okay, so it's not like close to 0 is 1.
Yes.
Yeah, because it's 0, so you have to do, you basically have to just multiply it out. Cancel out?
Yeah, it's in the B sign.
No, are you sure?
I'm just saying that you have to.
Because you get 0, you can't just plug it in because you get 0 on the bottom because sine of theta and theta is 0 is 0. So you have to work it out like these problems are saying.
Okay.
But you can't just plug in the value because you still have to plug in the value. Like sine of something still has a value. I mean, unless you can just leave it like that, you should be able to leave it. Much easier for the second. The second, 4B is much easier.
So I keep hearing people say sine of 0 is 0. Good news, that's right. Okay, are we doing direct substitution? We're plugging in?
Tried it.
Okay. And if you do that, now when you're actually doing the direct substitution, that's when it's okay to not write the limit. Sine of 0 is 0. Sine of 0 is 0. Uh-oh, indeterminate form. So what? Try some algebra? There's not even any algebra here. You've got to go deeper into the toolbox. Deeper. Deep. Deep. Deep into like trig.
Wait a minute. Yeah, the equation.
If you square
The equation.
Everyone's looking around like that. It was there!
it wouldn't be sine squared. Oh,
There's a rule at sine squared.
I'm not sure if that's the same. Plus 1.
Yes, there is a rule that sine squared of theta plus cosine squared theta is equal to 1. However, we are not
No, we don't
sine
have
squaring
cosine.
anything. What you're looking for here is called the double angle identity. And Mr. Like, one of the things I always love about teaching the calculus BC kids is like once I've like reminded them of something once, I never have to do it again. Ever again. So like here it is, here's the one reminder, sine of 2 theta is equal to 2 sine theta cosine theta. There it is. That's your double angle identity. Sine of 2 theta equals 2 times sine theta times cosine theta. Now that's really helpful. It's 2 times sine theta times cosine theta. Limit theta approaches 0 instead of sine 2 theta. 2 sine theta cosine theta, denominator here. Sine theta, you guys see what happens now?
Yes. So now you get 2 cos theta.
Right, those guys can cancel out. I do not want to see 2 cosine theta. I want to see limit as theta approaches 0. I know, high expectations. Final answer, 2. Are we clearing the cobwebs off?
Hmm?
We're clearing the cobwebs off the brain.
Mm-hmm.
It's going to be okay. It's going to be okay. Okay, I'll give you 30 seconds for the next one. No pressure. Nice, Stephen. Oh wait, Stephen, can you do that one more time? You did something with your fingers, and I. Oh no, sorry.
Whoa.
Sorry, no, you was wrong. What's the problem? What's the problem friends are running into? What is cosine of 2 theta? You mean like what's the identity there? There's like 3.
Yeah.
And I bet we don't remember many of them.
No.
At all. Or was it?
So you're kind of like hitting a block because you're like, I don't remember the double angle identity.
Mm-hmm.
You don't need it.
Because there's a cos.
Then you can basic this one.
Right, you can plug it in.
What's the right answer? Why?
Because cos of 2 theta versus this one.
No,
We're also cos of theta will be. If you play in 0.
zero.
If we take the limit as theta approaches 0 in the numerator, what happens?
2 multiplied by 0 because you plug it in.
You've got cosine of 0 in the denominator, cosine of 0. Cosine of 0, 1.
I can do math.
So with 4b, direct substitution is fine. In 4a, you're right there. In 4b, direct substitution is fine. In 4a, direct substitution gets you the indeterminate form. That's the problem. Okay? I'm deliberately picking mean questions to push you, not to break you. Okay, I have different problems for that. I'm always going to push. If I'm not pushing, I'm not doing a good job. All right, so one last question. Problem number 2. And unfortunately, we're not going to get much into like this next round of practice, but I want to talk about number 2. Okay, I have a conversation with somebody near you. What's your strategy here?
Right, so t equals 1. So you can use, I'd probably use
Alright, so you're gonna use t squared.
You literally want to use both.
I mean, you can always use
Yeah.
T squared.
The answer.
But they're still get in.
t squared.
That'd be
Oh, it's just
one.
t squared, isn't it?
Yeah.
T squared becomes 1.
But I feel like that's
Yeah.
a trick.
What if it's not?
It's a
It's a piecewise function.
Yeah.
It's not a trig.
So it's just 1.
Yeah, it can't fit into it. Look at the
It fits in perfectly because it's
you can't fit into the top equation. It's only fit into the t squared.
That's just 1.
No, what's our
But
what are you arguing about?
I'd be that dude.
no,
on the
I'm
test.
just saying there might be like.
I know that's
Like
we
low
might,
on the test.
I'm pretty sure we're thinking.
On the test, I'd be that dude. I'd be like, but what if it's not?
We're overthinking this.
All right, friends. Let's pull it back together. So Polymon just made a strong statement. We're overthinking this. Possibly, but probably not. What are the ideas that are out there? You're frozen just for a little bit. Lewis, you're also frozen. Love to hear from any of these amazing individuals in the front. Go for it. What's your thought?
So since it says the limit of g of t as t approaches 1,
Yeah.
use the t that actually equals
This one?
is greater than 1.
Can you read this notation to me one more time? Hold phrase. You're still frozen. You're still frozen. Read that one more time. You said it perfectly. Read this one more time.
The limit of
Come on, we got five people at North Central that need you. One more time.
the limit of limit of g of t as t approaches 1.
There is a reason I keep pushing the approaches.
Right.
This limit question is not about what happens at 1. It's a question of what happens when you get close to 1. And what makes things really nasty when it comes to these piecewise functions, if I'm coming from the left of 1, I use one piece. If I'm coming from the right of 1, I use a completely different piece. Are all the friends okay? Okay, let's do this real fast. So we're going to have to consider 2 different limits. What's the limit as t approaches 1 from the left? Well, that's t minus 1 squared over t squared minus 1. And at the same time, I have to have a conversation of what's the limit as t approaches 1 from the right of t squared. One of these, super easy. The one on the right. I'm going to try direct substitution, I'm going to get 1. If I try direct substitution here, I'm going to get, is that 0 over 0? That's no bueno. We're going to do this real fast. So limit as t approaches 1 from the left, t minus 1 squared means t minus 1 and t minus 1. T squared minus 1 means t minus 1 times t plus 1. Good news. Cancel, cancel. What's that limit?
1/2.
Oh, so awkward.
Wait.
Not 1/2.
T gets close to 1.
Oh.
0 in the numerator, 2 in the denominator. Final answer is
0.
0. The limit as t approached 1 from the left was 0. The limit as t approached 1 from the right was 1. The only right thing you can say now is
Does not exist.
the limit does not exist. And the conversation we had in the beginning, limit as t approaches 0 of g of t, does not exist because,
The limit from the right is
right, limit from the left not equal to limit from
The right.
the right. Everybody good? All right, see you guys later.
Wow. I just like blew my mind like
So you need to take this.
Don't worry, we're gonna start to go faster pretty soon.
we don't have to. but-
No. No, I gotta take the parking brake off.
Is that what you call it?
It wasn't
I call it the emergency brake. but okay.
already out.
All right, y'all, see you later.
I like
Yeah, I like the way you learn.
what?
This one likes hard enough yet?
Do I stop recording?
Not hard enough yet. This one likes pain, I can tell. Mr. Spielberg, thank you for everything. Live an amazing human. See you later. Enjoy the rest of your day.
There's gonna be something to it.
I know.
It's too simple.
When he said he put us on freeze, I started looking at it. I was like, wait a minute. So I was like, something's not right. We're not right. I was like, we're not right.
There's something to it. 'Cause that's my main problem. Even in
Oh, Polymo, you got more problems than that.
I know, besides not having a pencil and paper. Well, even, I'm talking about even in my past math classes. I would always overthink it, and then by overthinking it, I wouldn't notice the small details.
Gotcha.